Renowned Japanese geoscientist Hiroki Kamata has issued a dire warning that has captured the attention of disaster preparedness experts across Japan. A massive earthquake in the Nankai Trough region is no longer a distant possibility. It is now considered almost certain and could strike as early as the 2030s. Even more concerning is Kamata's assertion that such a megaquake could trigger a chain reaction culminating in a powerful eruption of Mount Fuji, Japan's tallest and most iconic volcano. Kamata's warning draws heavily on historical precedent and modern seismic data. The Nankai Trough, a major subduction zone off the southern coast of Japan, has produced devastating earthquakes in the past, roughly every 90 to 150 years. The last major event occurred in 1946. According to Kamata, the tectonic pressure in the region has reached a critical point, and a magnitude 8 to 9 earthquake is highly probable in the coming years. But Kamata's concern goes far beyond seismic shaking. He points to the very real and alarming risk of a volcanic eruption at Mount Fuji, which has been eerily silent for over 3 centuries. Since the 2011 Great East Japan earthquake, the magma chamber beneath Mount Fuji has become increasingly unstable. Kamata warns that the volcano is no longer dormant but on standby. If history repeats itself, a massive quake could trigger a major eruption, just as it did during the Hoei eruption of 1707. That historical event saw a magnitude 9 earthquake strike the Nankai, Tokai and Tonankai regions, only to be followed 49 days later by a violent eruption of Mount Fuji. At the time, volcanic ash fell as far as Yokohama and Edo, modern-day Tokyo, disrupting life for hundreds of kilometers. The implications of a modern Mount Fuji eruption are chilling. Kamata describes a scenario where thick volcanic ash blankets densely populated regions, shutting down transportation, choking water supplies, disabling power grids and overwhelming communications systems. Entire cities, including Tokyo and Yokohama, could experience service blackouts, impassable roads and economic paralysis. Life as we know it could be pushed back centuries to a state comparable to the Edo period. Japan is home to 111 recognized active volcanoes, and Kamata has warned that several of these, such as Mount Hakone and Mount Kusatsu Shirane, have already shown signs of post-earthquake activity. This suggests a fragile balance in Japan's volcanic system, one that could be tipped by a single large earthquake. The Japanese government has estimated economic losses from a Mount Fuji eruption to be around 2.5 trillion yen. However, experts including Kamata argue that this number severely underrepresents the true scale of damage. When a major earthquake and volcanic eruption strike simultaneously, the total cost could skyrocket into the hundreds of billions of yen, affecting not just infrastructure and public safety, but also financial markets and global supply chains. What makes this situation particularly grave is the amount of time that has passed since Mount Fuji last erupted. The 1707 Hoei eruption marked the end of a 200-year quiet period. Since then, over 300 years have gone by, far exceeding the typical eruption interval of 50 to 100 years. Scientists now believe that significant magma has accumulated beneath the volcano. This built-up pressure, once released, could have catastrophic consequences. Recent simulations only reinforce the severity of the threat. In the event of a full-scale eruption, cities like Gotemba, located near the eastern base of Mount Fuji, could receive ashfall of up to 1 to 2 centimeters per hour, accumulating to 120 centimeters over 15 days. Yokohama is expected to be buried under 10 centimeters of ash, while Tokyo's Shinjuku district could receive over 1 centimeter. Even areas more than 100 kilometers away would begin to feel the effects within 10 days. Critical infrastructure, highways, railways, airports, telecommunications and financial institutions could be brought to a standstill, sending shockwaves through every aspect of society. Kamata emphasizes that this warning is not meant to induce panic, but to catalyze preparedness. Japan is globally recognized for its robust disaster response systems, yet a dual disaster scenario like this demands unprecedented levels of coordination, investment and public awareness. Emergency plans must be revised, infrastructure must be reinforced, and communities must be educated on evacuation and survival protocols. Beneath the ocean's surface, at a staggering depth of 4,500 meters, lies a geological formation capable of unleashing devastation across much of Japan before mid-century, the Nankai Trench. This deep-sea subduction zone has long been associated with some of the most catastrophic earthquakes in Japan's history. Scientists and government agencies warn that within the next few decades there is a high probability that a colossal earthquake reaching magnitude 9 or higher will erupt along this fault. If unprepared, such an event could claim the lives of over 300,000 people. What makes this prediction so compelling is the overwhelming geological evidence. Japan sits at the intersection of four massive tectonic plates: the Pacific, Philippine Sea, Eurasian and North American plates. These plates converge in a fiery, shifting frontier known as the Pacific Ring of Fire, a volatile, horseshoe-shaped zone circling the Pacific Ocean, where nearly 90% of the world's earthquakes erupt. Japan lies directly in the heart of this seismic crucible. Within this turbulent boundary is the Nankai Trough, a subduction zone stretching from Suruga Bay near Shizuoka Prefecture, past the Kii Peninsula and Shikoku, and down toward the southern edge of Kyushu. Here, the Philippine Sea Plate relentlessly pushes beneath the Eurasian Plate, causing immense pressure to build along the fault. This tectonic stress doesn't disappear. It accumulates over time until it is violently released in the form of megathrust earthquakes and accompanying tsunamis. Although the Nankai Trench is not as deep as other oceanic trenches, its geological behavior makes it one of the most hazardous. Its proximity to densely populated coastal regions, including cities in Shikoku, southern Honshu and Kyushu, amplifies the risk. These regions are highly vulnerable not only to ground shaking, but also to the massive tsunamis that often follow. The historical record speaks volumes. Major quakes have repeatedly struck this trench in the past, following a pattern that now drives modern-day concern. Scientists understand that tectonic energy is continuing to accumulate. While pinpointing the exact timing remains impossible, the eventual rupture of this fault is not a matter of if, but when. Geological records and modern seismic data increasingly point to the onset of a new seismic cycle in the Nankai region of Japan. So significant is this looming event that it bears a specific term in Japanese, Nankai Trough Kyodai Jishin, which translates to the Nankai Trench mega-earthquake. Japan's long history of powerful tremors linked to the Nankai Trench has left indelible marks on its landscape and society. This seismic zone remains a focal point for disaster preparedness and scientific monitoring. Several historically devastating earthquakes have originated along or near the Nankai Trough. Among the most catastrophic was the Hui earthquake of 1707, estimated at magnitude 8.6 to 8.9. It unleashed a towering tsunami that battered southern Japan, particularly Shikoku and the Kii Peninsula, destroying communities, ruining farmland, and claiming over 5,000 lives. This disaster remains a key model for anticipating future megaquakes. Another major event occurred in 1854, an earthquake registering at magnitude 8.4. This quake formed part of what researchers call the double Ansai event, two massive quakes striking within 32 hours. The dual shocks led to approximately 3,000 fatalities, widespread fire outbreaks, extensive structural collapse, and a tsunami that devastated coastal regions. In 1946, a magnitude 8.1 earthquake again struck the Shikoku and Kii regions, resulting in the deaths of more than 1,300 people and widespread damage to ports, buildings and rural infrastructure. That same year, the Tokai earthquake, also with a magnitude of 8.4, shook the neighbouring Tokai area. Although not directly within the Nankai Trench, it highlighted the interconnectedness of seismic faults in the region. It inflicted heavy destruction on urban areas and resulted in over 10,000 deaths, making it one of Japan's deadliest quakes. Though geographically distant, the 2011 Tohoku earthquake, with a magnitude of 9.0, serves as a chilling contemporary example of the destructive potential of subduction zone quakes. The resulting tsunami not only killed over 15,000 people but also triggered the Fukushima nuclear disaster, sending economic and humanitarian shockwaves across the globe. The recurrence of such catastrophic events offers a stark warning. The Nankai Trench is not dormant, it is primed to unleash its built-up energy once more. Seismologists have spent decades studying this region, noting the surprisingly regular occurrence of large earthquakes at intervals of roughly 100 to 150 years since the 7th century. The last major rupture occurred in 1946, indicating that tectonic stress has been accumulating for nearly 8 decades and could be released soon. Dr. Yoshihiro Kaneda, a prominent Japanese geophysicist, has led extensive research into plate deformation in the Nankai Trench. His findings confirm the region's historical seismic rhythm and highlight a high probability of a major earthquake occurring within the next 30 years. Meanwhile, seismologist Ryota Hino of Tohoku University has developed detailed models simulating rupture dynamics and tsunami behavior. These simulations suggest that a future megaquake in the Nankai region could unleash an enormous tsunami, placing an estimated 323,000 lives at risk. Some of the most advanced seismic models, including those developed by Professor Shinji Toda of Tohoku University, an expert in fault segmentation and cascading rupture phenomena, indicate that the next major earthquake along the Nankai Trough could unleash devastation on a catastrophic scale. Real-time data from GPS arrays and seabed sensors confirm that the tectonic plates in the region remain tightly locked. The accumulated strain already corresponds to an event potentially exceeding magnitude 8.5, placing it firmly within the realm of massive subduction zone quakes, on par with disasters like the 2011 Tohoku or the 2004 Sumatra earthquake. An earthquake of this caliber would release energy equivalent to the detonation of millions of atomic warheads. Such a release could easily become one of the most destructive natural events in Japan's recorded history. The looming danger is not merely theoretical. Seismic hazard assessments published by Japan's Meteorological Agency, JMA, the National Institute of Advanced Industrial Science and Technology, AISE, and other research institutions have pinpointed several critical regions at heightened risk. The coastal prefectures of Kochi and Tokushima in Shikoku, Wakayama and Mie in the Kii Peninsula, the Tokai coastline, especially Shizuoka and Aichi, as well as major metropolitan centers like Nagoya and Osaka. Even Tokyo, particularly the soft-soiled zones surrounding Tokyo Bay, is vulnerable, due to the potential for soil liquefaction and seismic wave amplification. Beyond the shaking itself, the tsunami generated by such a rupture is perhaps the most harrowing threat. Dr. Koshun Yamaoka of Nagoya University, whose research specializes in seismic wave dynamics and tsunami modeling for the Tokai and Nankai regions, has created simulation scenarios that project tsunami waves surpassing 20 meters in height. These waves could push several kilometers inland, engulfing infrastructure, overwhelming sea defenses, and endangering nuclear facilities, ports, and entire coastal communities. Many existing coastal barriers, while robust, were not engineered to withstand tsunamis of this magnitude. The sequence of events likely to unfold during the anticipated Nankai megaquake would begin with a rapid slip along the subduction boundary, as the Philippine Sea Plate suddenly thrusts beneath the Eurasian Plate after decades of stress accumulation. This abrupt movement would trigger a release of seismic energy that radiates outward in the form of P waves and S waves, primary and secondary tremors that would reach densely populated coastlines within seconds. Vertical shifts in the landscape are also expected, with some regions rising or subsiding by several meters. Fortunately, Japan's world-renowned early warning systems stand as a vital line of defense. These systems can detect the faster, less destructive P waves and issue alerts through mobile networks, television broadcasts, public transport systems, and industrial facilities. Though warnings may provide only 10 to 30 seconds of advance notice, this brief window can mean the difference between life and death. Enough time for people to move to lower floors, halt trains, or trigger emergency protocols. Tsunami waves would likely arrive just minutes after the initial quake, with some coastal areas, particularly those along Shikoku, Ki, and Tokai, expected to be struck within 5 to 10 minutes. In low-lying zones, seawater could inundate up to 5 kilometers inland, making immediate evacuation critical. Japan has long been a global leader in earthquake resilience. In anticipation of a future megaquake, comprehensive strategies have been enacted to safeguard both citizens and infrastructure. Reinforcements to buildings, bridges and transportation networks in high-risk areas are ongoing. Nationwide emergency drills, such as those held annually on September 1st for Disaster Prevention Day, engage millions in simulations based on real-world disaster scenarios like the one expected from the Nankai Trough. Meanwhile, integration of early warning technology into homes, schools, and public communication systems ensures that alerts reach citizens in real time. But the potential impact of a Nankai Trench megaquake extends far beyond Japan's shores. As a central hub for global manufacturing, particularly in electronics, automotive engineering and advanced technology, Japan plays an indispensable role in the international economy. A disaster of this magnitude would disrupt global supply chains, affecting industries and consumers across the world. The ripple effects would be felt not only in the ground beneath Japan, but in every corner of the interconnected modern world. Japan, ranked as the third largest economy in the world, holds a pivotal role in global financial stability. A catastrophic disaster inflicting billions in damages could send shockwaves through international markets, potentially igniting a worldwide economic downturn. While Japan would bear the brunt of the destruction from a major seismic event, the impact would not stop at its shores. A tsunami generated by such an earthquake could surge across the vast Pacific Ocean, striking nations with coastlines including South Korea, Taiwan, the Philippines, Hawaii, Mexico, and the entirety of Central and South America. Among the most volatile seismic zones on Earth lies the Nankai Trough, a deep underwater trench notorious for generating some of Japan's most devastating earthquakes. Though scientists cannot predict the precise moment or nature of the next rupture, extensive geophysical studies indicate a high probability of a magnitude 9.0 earthquake within the next 30 years. Such an event poses a profound threat, not only through violent ground shaking, but through its potential to unleash a colossal tsunami capable of taking hundreds of thousands of lives. Meanwhile, a persistent and unusual sequence of seismic activity has gripped the Tokara Islands in southern Japan, alarming residents and drawing the close attention of scientists. Since June 21st, 2025, an earthquake swarm has unleashed at least 474 individual tremors in this remote island chain, part of Kagoshima Prefecture. Among these, several have reached magnitudes as high as 5.1, with ground-shaking intensities measured at Shindo level 4, strong enough to jolt households, rattle furniture and disrupt daily routines, although not typically causing structural damage. This seismic swarm has not followed the typical single shock pattern of most earthquakes. Instead, it represents a continuous series of low to moderate magnitude tremors occurring over several days, each one echoing through the archipelago and stirring concern among local communities. The Japan Meteorological Agency, JMA, which has been closely monitoring the events, reported that many of the quakes originated at depths of 10 to 20 kilometers beneath the Earth's crust, a zone known for intense tectonic friction due to the convergence of the Philippine Sea Plate and the Eurasian Plate. Toshima Village and neighbouring islands have felt the brunt of this geological unrest. Although no casualties or major property damage have been confirmed, the psychological toll on residents is palpable. Every tremor serves as a reminder of the volatile forces rumbling beneath their feet. With each passing hour, locals have found themselves checking government alerts and listening for updates, uncertain whether the next quake might be the strongest yet. In response, the JMA has issued advisories urging residents to stay vigilant, warning that this pattern could potentially escalate into a more powerful seismic event. The Tokara Islands form part of the Ryukyu Arc, a geologically dynamic belt stretching southwest from Kyushu toward Taiwan. This arc has long been recognized as one of Japan's most earthquake-prone and volcanically active zones. While earthquake swarms like the current one often dissipate without incident, geologists note that not all swarms end quietly. The 2000 earthquake swarm in the Izu Islands, for instance, escalated over weeks and resulted in significant geological changes, including ground deformation and volcanic gas emissions. Such historical cases weigh heavily on the minds of scientists watching the Tokara activity today. The JMA's real-time seismic intensity monitoring system has recorded Shindo values between levels 2 and 4 across affected areas, particularly in Toshima village. These values, though generally non-destructive, indicate movement strong enough to be distinctly felt indoors, causing hanging objects to sway and prompting concern among island residents accustomed to seismic activity, but not at this frequency or persistence. Importantly, as of June 26th, the JMA has not issued any tsunami advisories or special volcanic warnings for the region. No visible signs of volcanic unrest, such as gas plumes, thermal anomalies or ground swelling, have been detected. Nevertheless, authorities remain on high alert, and seismologists continue to analyze seismic waveforms and tectonic stress patterns in real time to assess whether this swarm is a prelude to something more significant. Japan's government continues to invest heavily in disaster preparedness and early warning systems. Yet in the face of such an overwhelming natural force, the question remains, can any level of preparation truly match the scale of what may come? If you found this video informative and thought-provoking, don't forget to like, share and subscribe. Your support helps us continue uncovering the stories that matter. Stay safe, stay aware, and thank you for watching.